In this module, we're dealing with limiting reactants and percent yield. First of all, what a limiting reactant is. In any real-life chemical reaction, one of the reactants will run out first. When that happens, the reaction stops because you need all of the reactants for that reaction to proceed. The reactant that runs out first, that's the limiting reactant. And the limiting reactant determines everything. It determines how much of the products there are, determines how much of the excess reactant or the other reactant there is left over. And of course, there will be no limiting reactant left over. It's all gone. So let's look at this reaction here. Aluminum reacting with copper 2 nitrate to make aluminum nitrate and solid copper. And let's say we have 1.5 moles of aluminum and 2.1 moles of copper 2 nitrate. We want to find the limiting reactant. Well, the way this is commonly done is you pick a product, doesn't matter, any product, and you calculate how much of that product you could make from each of your reactants. Whichever reactant makes the least amount of the product is the reactant that would run out first, and that's the limiting reactant. So if we have 1.5 moles of aluminum, again using our mole-to-mole ratio from our balanced equation, we see that we can make 3 moles of copper per every 2 moles of aluminum, and we calculate about 2.3 moles of copper can be produced from this many moles of aluminum. Doing the same for the moles of copper 2 nitrate, we see that we can make 2.1 moles of copper. Because this is smaller than this, we know now that copper 2 nitrate is our limiting reactant. And that way always works. But there's a shortcut that I use. So all you have to do to find the limiting reactant, and this always works, there's no exceptions, is once you find how many moles of each reactant you have, just divide that number of moles by the coefficient in the balanced equation. Whichever of those gives you the smallest number, that's the limiting reactant. Real easy. So in our example we just did, we had 1.5 moles of aluminum, and remember the coefficient for aluminum was 2, coefficient for copper 2 nitrate is 3, so if we take 1.5 moles of aluminum divided by 2, we get 0.75. Do the same thing for copper 2 nitrate, dividing by 3, because its coefficient was 3, you get 0.70. Well, 0.70 is less than 0.75, so we know right away that copper 2 nitrate is the limiting reactant. This is the way I do it. It's quick and it always works. Now, we almost never are given moles. It's almost always grams or something like that. So this is more like what you'd see. Let's say we have 0.519 grams of hydrogen and it reacts with 2.93 grams of oxygen. We want to find what the limiting reactant is. Well, the only thing that's different is we have to find the moles first. So we just divide by the molar mass, we get the moles of each. This is the molar mass of hydrogen, this is the molar mass of oxygen. We get moles of hydrogen, moles of oxygen, divide each by their coefficient in the balanced equation. So here hydrogen's coefficient is 2, so we divide moles of hydrogen by 2 and get 0.129 or so. Same thing for oxygen, divide by 1, we get 0.0915. So because this number is smaller than this, we know that oxygen is the limiting reactant. Now, a word of caution. Cross these numbers out. Throw them out. Get rid of them. Kick them out. They're no good once you've used them to find the limiting reactant. And a common mistake is for people to use these numbers here for further calculations, and that will mess you up most of the time. So they're great. You find these numbers, use them to find the limiting reactant, then throw them out. So we almost never stop at just finding the limiting reactant. We always want to know something else, like how much of this product can we make, for example. In all stoichiometric calculations, moles of the limiting reactant is the starting point. Let me say that again, it's that important. In all stoichiometric calculations, moles of the limiting reactant is the starting point. All right, so let's say we have that same reaction, same amount of hydrogen, same amount of oxygen. We just calculated that oxygen is the limiting reactant, and in that process, we calculated how many moles of oxygen there were. You'll always do that. So the moles of the limiting reactant, which is oxygen, is the starting point. So all we do is use our balanced equation, our stoichiometry, mole-to-mole ratio, to go to moles of water, and then we use the molar mass of water to get the grams of water. So about 3.299 grams of water can be produced theoretically. Why do I say theoretically? Well, because that's what we call the theoretical yield. In almost every chemical reaction that you do, you don't get the same amount as you calculate that you should make. You don't get your theoretical yield. you get your actual yield. Your actual yield, it's just how much you actually make. In the lab, it's how much you weigh at the end of the experiment. In problems, you have to be given the actual yield. Theoretical yield, you always calculate that like we just did. That number that we just calculated, the 3.299 grams of water, that's the theoretical yield. Percent yield is just actual yield over theoretical yield times 100. Memorize that equation. All right, so let's say we did that chemical reaction, and so we already figured out that oxygen was the limiting reactant, and we figured that the theoretical yield of water was 3.299 grams. Let's say we do that reaction, but we only end up with 2.14 grams of water. What's the percent yield? Well, it's just our actual yield, 2.14, divided by our theoretical yield, which we calculated, times 100, and it's about 64.9% yield.